So this is kind of the introduction to this qualitative analysis and chemical bonding lab. We'll be looking at some key features of covalent bonds, ionic bonds, metallic bonds, and when it comes to covalent bonds, polar and non-polar bonds. So we're going to start, and you'll notice here that there's 12 files up at the top. Later on in this lab, we'll be taking each one of these and finding out some key attributes of each of them. But first, we have our 4 samples here that each represent a different type of bond. So you'll notice here we have some zinc, of course being a metallic bond. We have copper sulfate here, copper sulfate of course being ionic bonding. Dextrose, which is kind of a sugar, is actually a polar covalent bond. And paraffin wax is a non-polar covalent bond. So we have each of these, and we'll be testing some of the attributes for each, mainly the color and appearance, their solubility in water, hexane and alcohol, the melting point, their conductivity, as both a solid and solution, the pH of the solution, and whether or not they react with hydrochloric acid and sodium or sodium hydroxide. So here we are. We have 4 little stations to work with to begin with. So we're going to start here with the zinc over here on the left. I'll put just a little bit of this onto our little station here. You can see it's kind of it's finely like granular, but it's pretty shiny. Again, I'm not sure how well the camera's picking that up, but it's pretty shiny. It's a metal, of course, so that is one of the key attributes, I suppose. The next one here is copper sulfate. We always think of this as like having crystalline structures, right? So that's what we can see here. Copper, the copper, of course, making it relatively blue. Here we have dextrose, which is sort of a sugar. If you know what sugar looks like, this is kind of just a fine sugar, I suppose you could say, because yeah, it is very, very fine. And paraffin wax. If you've had, like, I don't know, braces, you've seen some of these before. They're beads, kind of. They're waxy, they're soft, they're bendy. You can squish them with your fingers. So that's paraffin wax, in case you weren't familiar. Anyways, the first thing that we'll be doing is we'll be looking for the solubility in water for each of these 3 things. So here we got some water. So we'll just go ahead and add some water to each one of these. Adding it to the metal, as you might expect, does not really seem to be doing a whole lot. Now with copper sulfate, we've used copper sulfate before, so we expect this one to dissolve because we've seen it before. We'll just let that sit for a little bit. Add it to the dextrose as well. Again, this is kind of familiar territory. If you've ever, I don't know, made Kool-Aid, you've seen that sugar dissolves in water. So, again, when we let that sit for a little bit, probably will notice that. And here with paraffin wax, again, kind of as you might expect with putting wax in water, probably not going to dissolve there. So we'll let this sit for a little bit, and we'll come back to it. So here we've just let this sit for just, I don't know, probably a minute even. And here's the zinc. You can see the zinc's kind of on the edges, the water kind of pushes it out. No dissolving, kind of as you'd expect with water and metal. Here, you've got the copper sulfate. You can see there are a few crystals still in there, but if we gave it some time, those would dissolve too. Copper sulfate is soluble in water. Next one we've got here is dextrose. Again, as you can see, it kind of just looks like water because sugar is soluble in water. So there's that one. And here with paraffin wax, you have the beads just floating on top of the water, as you'd expect. So remember that zinc represents metallic bonding, copper sulfate represents ionic bonding, dextrose represents polar covalent bonding, and paraffin wax represents nonpolar covalent bonding. Okay, the next thing here that we're going to do is we're going to go ahead and test pH levels from each of these solutions. Even though, for instance, with the zinc one, it didn't dissolve, we're still going to test the pH. Copper sulfate. Dextrose. And the paraffin wax. When we compare these pH levels to what we see on the chart here, you'll see this one's kind of green, so we'd maybe say this is between a 7 and an 8 over here for paraffin wax, kind of what you'd expect from distilled water. So here, yeah, kind of just what you'd expect from distilled water. Here with the dextrose, this one's kind of orangish. We may maybe say 6 here. For the copper sulfate, it's a little bit darker actually, so you might be able to go 6, maybe 5 even. And here for the last one over here, the zinc, it's orange, but there's some green in it too. It's not really yellow like a 7, so probably 6, 6.5, somewhere between the 6 and 7. So that's just some pH levels of these solutions. Do a very similar process again here for more solubilities, but this time we're going to be using hexane and some ethyl alcohol, just any alcohol really, to get some more data points. So I'm just going to go ahead and put some more zinc in this one and all the way down. Serving trays all set up, so we can go ahead and add some. We'll put hexane on the top row and alcohol on the bottom row. All of our things set up. So we see here the zinc with the hexane looks the same as usual. The copper sulfate, the copper sulfate in the hexane also not dissolved at all, which is a little peculiar because we know that it dissolves in water, but not in hexane. The dextrose has slight dissolving. I'm not 100% sure how well you could see it, but it does look like it's dissolved a little bit, but not all of it, of course, so maybe we'd call that a slight dissolving, or slight solubility, my bad. And with paraffin wax, we see that it's actually changed, so it doesn't look like this. So we'll do maybe a better representation here. So we have a little beaker here of hexane, and we're going to go ahead and add maybe 1 bead of paraffin wax too. I guess 2 if we have to. And then we're going to let those sit for a little bit while we go through the ethyl alcohol. So in ethyl alcohol, zinc, no. Copper sulfate, no. Dextrose, no. And paraffin wax, no. This is same old boring paraffin wax. This one though, I hope you can see a difference. It's way lighter up here. So something's happening, and we'll just let these sit a little bit longer to find out what. So we let this hexane and the paraffin wax sit for a little while, and the paraffin wax has actually gone into solution, believe it or not. It's kind of hard to believe, but paraffin wax, we know, is a non-polar covalent bonded material, which should dissolve in hexanes since they are also nonpolar. So that is something that happens. It's just hard to see with such a small amount of hexane and so much of the paraffin wax. There's also some other attributes about each of these to know. For instance, all of them have a melting point above 100 degrees Celsius, except for paraffin wax, which melts lower than that. Additionally, the two that go into solution, the copper sulfate and the dextrose, only the copper sulfate conducts as a solution, and only the zinc conducts as a solid. So yeah, that's just some other information to know about each of these and to help us figure out what these 12 items are later on, based on how their bonds are formed. So here we are, we're now going to move into the second part of this lab, trying to identify what each of these 12 items are. So I'm going to be demonstrating some things with each of them, some just procedures to try to figure out what each of them are. So we're going to start here with number 1. So you can see here it's sort of a white crystal-like structure. If the camera will focus, there we go. It's some sort of like maybe ionic, I don't know, it's just crystalline structure. So I guess there's two things we're really going to do to test this one. First thing is we're going to get just a small amount of it. If we can here, we're going to put a small amount of it onto our dish. And we're going to test the pH level by adding some of the water. There. See first off, of course, if it dissolves, which is the first step. And the second thing that we're going to try with this one is we're going to take a very small amount of it, put it on the black table, and see if you can write with it with your finger. There's no real residual being left on the table, so we could just clean that up a second. And maybe the third thing to do is to test its reaction with some hydrochloric acid. So we have some hydrochloric acid here, so we're going to test the reaction with hydrochloric acid. So here we go, we're going to add some of the hydrochloric acid into this one. Let's get a little bit into the pipette. And no real reaction seems to be taking place there, so that's just another indication. We will, however, go ahead and test the pH level now, using one of our pH strips like this. Get some of it in there. And compare the color here to what we see on the chart. It's pretty dark, so it's probably either a 3 or 4. Having a pH of 3 or 4 indicates that this might be some sort of acidic situation going on here. So yeah, that's number 1, and we'll repeat the same process for number 2 and onward. So we're done with number 1, so we'll just set it off to the side. And we've actually got number 2 here now. It's a metal, it appears. So go ahead and maybe get one of these pieces out, or a few of them. First thing that we really want to do with metals to test if they're magnetic or not, we have just a magnet. This is actually one of the stirring things from like the titrations. This metal is not magnetic, which tells you something. Also looking at it, it's just small little piece. But yeah, so it's not magnetic. There's not really a whole lot else we can do with metal with our current situation. It's not magnetic is really the kind of big takeaway. Got number 3 here now, which again, just like number 1, is kind of like a white powdery substance. This one reminds me of like powdered sugar, though. It's much finer. The other one reminded me a little bit more like sugar. This is powdered sugar, much finer, almost flourish. So again, there's a couple things we want to do here. The first thing that we want to do is kind of, get its pH level. So we'll get a small amount of it there. We'll also test its reaction with hydrochloric acid, and we'll also test writing on the table with it. So I guess the first one is, does it dissolve in water? So we'll let that sit for a little bit. Maybe give it a stir with stir stick or something. The next is, I suppose, how does it react with hydrochloric acid? Not sure if you can see that, but there were some bubbles that just formed, believe it or not. Yeah, okay, here, I'll try to get the camera much closer to that one. You can see all the bubbles forming at the bottom there, from the reaction with the hydrochloric acid. So that's kind of a really strong indicator. But just to, like, confirm our knowledge, I suppose, we'll just try writing on the table. Which you can see it's leaving a pretty distinct path that if you were to write, say, your name or whatever with it, you can. So it's another big indicator for number 3. Hopefully that gives you some information. Numbers 1 through 3. This is number 4. This is much different than the other ones that we've been seeing before. I'll remove the lid a second, but this is a liquid of sorts. So one of the things to think about with the liquid is this has an extremely low melting point. This is room temperature, probably about 23, 21, something there, degrees Celsius. And number 4 here has melted, or it's become a liquid. So that's pretty much the only clue that we really need for number 4. It's just a liquid at room temperature. It's like an extremely low melting point. Got number 5 here now. Hard to describe. It's just sort of white powdery thing, just like other ones we've seen before. One of the big clues that we can get from it is whether or not it's soluble in water. So we'll take some distilled water here and add it to our tray. Pretty immediately on this one, you can see that it is soluble in water. Not all of it's dissolved yet, but a good chunk of it sure has. We'll also go ahead and take a little piece of pH strip, just to get a good amount on it there. We'll compare the color now. Hopefully you can see here, I'm not sure how well it's coming through, but it's kind of orangish on the right, but a little bit green on the left. We'd say this probably is somewhere between the 6 and 7 range. It's not quite as yellow as this, but it's not quite as orange as this. So this has pH of about 6.5 is what we'd probably say, which is kind of the only data point you really need for this one. I suppose another thing to consider about number 5 is how it looks. So again, we'll put a little bit more on the table here. Oops, that's a big chunk, but It reminds me a little bit of sugar. It's got a coarse feeling to it. You can't write with it. So it's a sugary substance, I suppose we could call it. We're going to go ahead and work with number 6 here. It's a metal that's a powder. It's a powdery like metal. There's really 2 things we're going to test with this one. We're first going to test magnetism. So, I don't know how well you can see this, but if you look on the side here, we're going to draw the magnet across it. And the powdery metal does not seem to be magnetic. Oh wait, I just realized the camera was sort of out of focus, so we're going to fix this and do it again. I'm going to draw the metal, or the magnet, across the metal, and it's not really picking it up, it's not really moving, so I'm going to say that this is not magnetic either. So the first metal had metal pieces, and was not magnetic. The next one is a sort of powder, and not magnetic. The other thing that we want to do with this one is test whether or not we can write with it, which I'll explain in just a second. So this is obviously darker, so we're not going to do it on the table, but we are going to go ahead and take just a little bit of it, put it on a white sheet of paper. Here we go, we got a little piece there. So we're going to go ahead and drag our finger across, just like we did with the other one. This one, you're probably familiar with how this one writes, actually. Maybe take just a little bit more. Oop, that was a little much, but it's okay. So again, you could drag it across the piece of paper. And you'll notice this one does write. When you shake it off, it doesn't come off the paper. So that's the one thing you could tell there from this one, which is number 6. And we've got our number 7 here, which very clearly is this bright red powder. If it reminds you of anything, you'll notice how it's powder, but it's color. Which reminds me personally a little bit of the calcium. Wait, what was it the other day? We used copper 2 sulfate, which was blue. So it sort of gives you an indication that it's sort of ionic because the color has affected the way it looks, or the color is affected by the ions probably in it. The one thing we can check, just to like confirm our guess, I suppose, we're gonna go ahead and put some of this on our plate, and then add water. Whether or not this is soluble in water will be a clear indication of what it is. So we're going to go ahead and let that one sit just for a little bit. So we've let this sit for a while now, so we'll get a closer look. Sorry about that. Extremely rocky ride down, I suppose. Yeah, I don't know if you can see this, but it does not appear to be soluble in water. All of the sort of dust that we had at the beginning is still there, just it's at the bottom of the dish, so not soluble in water. Right, here we are with number 8. This is another seemingly fine metal. So just like we did with the other metal, there's 2 things we're going to test. 1, whether we can write with it, and 2, whether it's magnetic or not. So the first one, magnetism, we can figure out using one of these magnets. So hopefully you can see that it is moving with the magnet. So this is a magnetic metal, just fine chunks of it. It's actually kind of fun to watch, but so that's just one of the indications for number 8 here. And the second thing that we want to do, just like we did with other, even though we already know that it's magnetic, so it gives us a pretty good indication of what it is, we'll also test whether or not we can write with it. So a small piece of paper here. Just get a few of the pieces of this metal on there. Close this up so if we spill it, it doesn't spill. And just go ahead and try to write with it. No, the answer seems to be no. This is not something we can really write with, which is, what we expected given that it was magnetic. Next one here, we've got number 9. So another sort of crystal white powder. Got a few of those actually. For number 10 is going to look like that too, and so is number 12. So we gotta have some way of distinguishing what these are. The sort of thing we'll do here is really, since we have to distinguish between them, one of the best indications is going to be pH level. So we'll put some of it there, then we'll add some of our water. First, it's important whether or not it dissolves, so we'll let it sit just for a second. And then we can go ahead and take one of these pH strips, get a little bit of it wet, take it out. We'll compare the pH strip color to the colors that we see here. So we've got number 9 here, or the solution of number 9 on a pH paper here. So we're going to try to match up the color. It's orange, it's kind of dark, it's a little wet, that affects it a little bit, but we think it's probably somewhere in here in between 5 and 6. The color is somewhere around there, so not too acidic, but slightly acidic, more acidic than just the regular distilled water would be. The next thing we could do with number 6 here is we could just take a little bit of it and try to draw with it. So moving it around doesn't seem to have any effect, or it doesn't leave residual. So not a super effective drawer. We're now going to work here with number 10, like we said earlier, also one of these white powdery substances. So again, there's basically 2 things we're going to try to do with this one. Yeah, that's much more powdery, almost floury, maybe powdered sugar. That consistency at least. We're going to add some of our distilled water to it, see if it's soluble in water. And we're going to try to just get this to dissolve. Okay, so it's not dissolving too great actually. So we'll take a piece of pH paper just to see if any of it's dissolved. Maybe it's only slightly soluble. So just grab a little bit of the solution and put it onto our pH paper. Okay, so after letting that one sit for a little while, after letting it get onto the paper, you can see that's pretty dark. It's definitely not quite as rosy as a 1 might be, but it's probably somewhere in between a 2 or 3. So it's not super soluble, but what does dissolve is super acidic, if that's any indication. Yeah, pH somewhere around 2, maybe 3, 2.5, so yeah. So we have number 11 here. It's, hopefully you can see, it's sort of metalish chunks. So we pulled one out here, and there's really 2 things we're going to be looking for with a metal chunk. And first off is obviously magnetism. So we have our magnet here again. And checking it, it does not seem to be magnetic. It's not sticking to the magnet. The magnet can't pull it across the table. So it does not seem to be magnetic. The other thing we need to check is we need to check continuity or conductivity. So we have our multimeter here, and we've turned it to the ohms setting. I have it on 20 M, which seems to work best for me. It's basically putting the charge through, and it lets the multimeter know whether or not the charge is getting all the way through. So just to confirm this to see what happens, when you click the ends, the meter should read something close to 0.00. It's just confirming that there is continuity, and when they're not together, it doesn't read 0.00. We're going to go ahead and take this and apply it to the metal. So yeah, there, hopefully you can see that it is reading 0.00. So there is continuity here. It is conductive as a solid. You can check this with metals too. So when you touch the two ends together, you'll see that this piece of metal is continuous. It is reading 0.00. So that's just the second check you really want to do with solid pieces of metal. And finally, we have our number 12. Basically, there's two things. It's another one of these white powdery substances. There's two things we're checking. One of these things, of course, is solubility and pH level. So we'll just get a little bit of this onto our plate. And the other is, and we'll actually add some water here real quick. And the other one is whether or not you can write on the escalator. As you can see, again, it kind of has the consistency of like sand or salt. It doesn't leave any residual either, so that was kind of a no-go. But the thing we do want to check, and we do hope works, is solubility and pH levels. So some of it does seem to be dissolving when you give it a stir, so that's a good sign. Let's grab a small piece of pH paper. We'll take some of our solution and pipette it onto the paper. So that's much different than what we've seen in previous ones. The strip is right there, which clearly is blue. The other ones we've been seeing have been orange, red, yellowish, even green. This is blue, so we have our indication chart. It's pretty dark, to be honest. It's much darker than a 9. Maybe it's somewhere between a 10 and 11, honestly. 10 seems to be the best to it, probably. But yeah, that's pretty dark. So that's kind of a nice giveaway. I mean, it's so distinctly different than other ones that we've seen before. And that's number 12. So that's all of the data that we really need to collect. Hopefully that gives you enough. It's showed you how you can identify certain things, given a list of options, and hopefully you're able to figure out what each of these 12 things are based on the data we've collected together. So yeah, I hope that helps, and that should be it. It also is a good review of how the bonds work for different types of bonds, as well as like what their functions are and what the properties of the materials with them are. And so yeah, hopefully that was a good review and everything, but should be good to go.